Section 3.6 is on multiplying matrices. In order to be able to multiply two matrices, if you look at this example, it says A times B. If A is an M by N matrix and B is an N by P matrix, notice these two inside dimensions. Those need to be equal in order for you to be able to multiply matrices. And then your answer is going to be these outside dimensions, okay? So you'll see here, we've got M by P. That's going to be your answer. Those are going to be the dimensions of AB. So first of all, I want to find out if I can actually take A times B. Well, if you look at these two inside dimensions for A times B, they're both 2. So yes, these are defined. You could take A times B. And then what are the dimensions going to be? It's going to be these outside 2, and they have to be in that order. So it would be a 5 by 2 matrix in the end. Now the next one, if I wanted to take A times B, if I look at these two inside dimensions, they are not equal. Okay, since they are not equal, then no, I cannot do A times B. Multiplying matrices, this is right out of your book. If you look here, if this is a 2 by 2 and a 2 by 2, I can multiply those, obviously, because the two dimensions in the middle are the same. Multiplying matrices gets a little funky because there's some extra steps involved. Notice here, this is row 1 of the first matrix. This is column 1 of the second matrix. What you're going to do is put those together. Okay, so if you look at this spot right here is row 1, column 1. And what they do is they take A times E and then add that to B times G. Okay, so let's do an actual multiplying matrices problem. First of all, check out the dimensions. Again, we have a 2 by 2 and a 2 by 2. Okay, since these are the innermost and they're equal dimensions, then it is going to be defined, and the dimensions at the end are going to be a 2 by 2. Okay, so you know right off the bat you're going to end up with a 2 by 2 matrix. Now let's multiply these out. This spot right here is row 1, column 1. So what I'm going to do is I'm going to take this row 1 in the first matrix times column 1 of the second matrix. So I'll take 2 times 1 and get 2 plus negative 3 times 3, which is negative 9. Okay, and that'll be row 1, column 1. Now if I move over to this spot, okay, I'm still in row 1, but now I've moved over to column 2. So now I'm going to go row 1, it's always the rows of the first matrix, times columns of the second matrix. Since this spot is row 1, column 2, then I'm going to take row 1, column 2, and put those together. 2 times negative 4 is negative 8, plus negative 3 times negative 2 is positive 6. All right? Now we're going to move down to row 2. This spot right here is row 2. Okay, so we always take the row of the first matrix, and this is column 1, so it'll be column 1 of the second matrix, and we'll put those together. It's always the first times the first, so it'll be 1 times 1 is 1, plus 5 times 3 is 15. And then we move over to the last spot, which is row 2, column 2. So now I'm going to go to row 2, always rows in the first one, column in the second one. So it'd be row 2, column 2. Again, take the first times the first. 1 times negative 4 is negative 4. Plus The second number times the second number, 5 times negative 2 is negative 10. Now we're going to put all that together to get our final matrix. If I add these up, 2 plus negative 9 is negative 7. Negative 8 plus 6 is negative 2. That's actually positive. 1 plus 15 is 16. And negative 4 plus negative 10 is negative 14. So there's my 2 by 2 final matrix. Now let's do one with some different dimensions. This first matrix is, notice it's got 3 rows. This is a 3 by 2. Okay, this one over here, 2 rows, 2 columns. So this is a 2 by 2. Okay, and again, check the inside dimensions. Those are the same. So I can multiply these and it's going to end up as the outside dimensions. So this is going to end up as a 3 by 2 matrix. So now let's put this together. Okay, it's going to be a 3 by 2. So I'm going to take row 1 times column 1 first. 3 times 2 is 6, plus negative 2 times 1 is negative 2. Okay, now we're going to move over to this spot right here, still in row 1, but now I'm column 2. So I go to row 1, column 2. 3 times negative 3 is negative 9. Negative 2 times 0 is 0, so this would be plus 0. Okay, now we're going to move down. Now I'm in row 2. Okay, so I'm going to go to row 2, and this first spot is in column 1. So I'm going to take these two together. 0 times 2 is 0. 4 times 1 is plus 4. Okay, now we move over to this spot here, still in row 2. Okay, but now we move over to column 2. 0 times negative 3 is 0, plus 4 times 0 is 0. All right. Now we move down to this spot, row 3. Okay, so we're going to take row 3, and we're in column 1 to start with. Negative 1 times 2 is negative 2. 5 times 1, so this would be plus 5. All right, and then the last one is going to be still row 3, but now we're in column 2. Okay, so that's this spot here. Negative 1 times negative 3 is positive 3, plus 5 times 0 is 0. So to finish this up, I'm just going to go ahead and do that addition. 6 plus negative 2 is 4. Negative 9 plus 0 is negative 9. 0 plus 4 is 4. 0 plus 0 is 0. Negative 2 plus 5 is 3. And 3 plus 0 is also 3. So there I have my final 3 by 2 matrix. You can see the reason why these inside dimensions work is because here I've got 2 numbers to match up with these 2 numbers. Okay, so I've got 2 columns, so there's 2 numbers in the 2 columns, and there's 2 rows, so there's 2 numbers there. So that's how that makes it so that those work out in order to multiply. Again, we have some properties that we can use for matrix multiplication. Notice that they are associative. Matrix multiplication is associative, so I can change the way I associate as long as all you're doing is multiplying. There is distributive property, okay? So if I have one matrix times B plus C, add those up, I can go ahead and distribute A times B, A times C. Then right distributive works the same way. Again, but notice it has to be A times C, B times C, okay? It does matter what order you multiply in, okay? If I say, can you multiply A times B? That doesn't always mean that you can do B times A. For example, let's say A is a 2 by 2 and B is a 3 by 2. Okay, you can see here A times B, you can't do that because these two inside numbers are not the same. But if I switch this around, B times A, if B is still a 3 by 2 and A is still a 2 by 2, notice I can take B times A because those innermost dimensions are the same. Okay, so A times B can't do, but B times A can do. So multiplication is not commutative with matrices. And that concludes 3.6.